You might be surprised to learn this, but during the Cold War, the U.S. Army actually had something like 5,000 nuclear artillery warheads
Yeah, 5,000.
deployed right across Europe with NATO allies. Just think about that for a second.
It's kind of wild, isn't it? And
Yeah.
it tells you a lot about the thinking back then. Tactical nukes weren't some far-off thing.
Aye.
They were seen as, part of the actual battlefield toolkit.
Integrated right in.
Totally. And deploying them like that, so far forward, well, it really changes the whole calculation for any potential conflict, doesn't it?
Absolutely. It kind of blurs that line between conventional war and nuclear war right from the get-go.
Exactly.
And that's pretty much what we're diving into today. We're exploring the U.S. Army's nuclear stuff as it was, well, back in the early 1980s.
Right.
Our main source is this document from around that time called Army Nuclear Weapons. It gives a pretty detailed look.
Yeah, it lays out the types of weapons, where they were, what they were supposed to do.
We're talking nuclear artillery shells, tactical missiles, even atomic landmines.
Atomic demolition munitions, yeah. It's quite a range.
It really is.
And you can see how it all fit into the bigger picture, the overall nuclear strategy. It wasn't just the huge ICBMs, the intercontinental
With
ones.
big ones, yeah.
Right, there was this whole other layer of tactical weapons meant for, well, battlefield use.
So our mission today, really, is to unpack this bit of history, pull out the key bits of info about these Army nuclear weapons for you, give you a good, concise understanding of this pretty significant part of Cold War history, the different types of tactical nukes, what they were for.
Like a shortcut to getting up to speed on it.
Exactly, because even though it's history, it kind of echoes today, right, in terms of security and strategy.
It definitely does. And it makes you think, when people say nuclear weapons, what pops into your head?
Probably the huge mushroom cloud, city-destroying bombs.
Right, but these tactical ones, they were a different beast entirely. Smaller scale, relatively speaking, but still unbelievably destructive.
Okay, so let's start with that nuclear artillery. We mentioned the number around 5,000 warheads in Europe.
Yeah, staggering.
And they weren't just U.S. weapons. The source lists 7 NATO armies that had them.
7, yeah. Belgium, Greece, Italy, the Netherlands, Turkey, the UK, and West Germany.
That's a lot of fingers potentially near the button, isn't it?
Uh-huh.
Shows serious allied integration, though.
It really does. A unified front, sure, but imagine the command and control complexity.
Oh, yeah. Coordinating all that across different national commands.
Wow. Must have been a nightmare, logistically and strategically.
So the document mentions 2 specific types of nuclear shells deployed back then. First, the M422. That was a 203mm projectile. It carried the W48 warhead.
Okay, the bigger caliber.
And then the M454, which was a 155mm shell using the W48 warhead.
Right, the standard NATO artillery size. So basically standard guns firing nuclear rounds.
Pretty much. And that W48, didn't another source say it had a relatively low yield?
Yeah, something like 0.1 kilotons, which sounds small, but, 100 tons of TNT equivalent. That's still massive.
Doom and Duke.
Absolutely. Reinforces that tactical idea, though.
Now, interestingly, there was another one in production, the M753, also 203 mil.
Okay.
This one was designed for the W79 warhead, which was an enhanced radiation type.
Ah, the neutron bomb.
Right, but the source says these W79s, while being made, were actually stored back in the U.S., not deployed yet in Europe at that point.
That enhanced radiation part is really significant. Neutron bombs, right? Designed to kill people with radiation, but do less blast damage.
Yeah, less damage to buildings and stuff.
Which is just a chilling concept. It sort of hints at this idea of maybe fighting a limited nuclear war.
Lowering the threshold.
Potentially, yeah. In some strategists' minds, anyway. The idea was to, take out tank crews without leveling the whole area. Terrifying.
It really is.
Yeah.
And the document points out how these standard artillery guns, the 155s and 203s, were increasingly adapted for this.
They were replacing older guns, right, like the 105s and 175s that couldn't fire nukes.
Exactly. And after they retired the Honest John rockets, which we'll get to, they actually increased the number of artillery guns in combat units to pick up the slack.
So artillery was becoming even more central, more versatile, capable of conventional and nuclear fire.
Imagine the logistics for those units, handling both types of ammo.
Yeah, must have been complex.
Organizationally, the source gives a bit of a breakdown. 155mm units usually had 18 to 24 guns in 3 batteries.
Okay.
The bigger 8-inch, the 203mm, they might have 12, 18, or 24 howitzers in 2 or 3 batteries.
Standard artillery formations.
Yeah, and it notes self-propelled guns tended to go with armor and mechanized units, keeping up with the tanks,
Makes sense.
while the towed guns went more with infantry, the lighter units.
But the really striking thing is that the nuclear warheads themselves,
Well, were kept available right there with the firing units.
Yeah.
In special trucks.
right there on the front lines, basically.
Exactly. Ready to go if the order came down. Which, psychologically,
Yeah.
wow, imagine being one of those soldiers.
Intense. But it wasn't all perfect. The document mentions they were hitting limits with nuclear artillery.
Practical limit.
Yeah. Things like range, noise, actually finding the targets, accuracy, reliability. They were becoming issues.
So even with all that power, there were constraints.
Right. Which led to trying to improve them. Naturally, newer guns came along.
Like the A1 and A2 versions of the M109 and M110?
Exactly. Longer tubes, muzzle brakes, stuff that pushed the range out significantly.
From what, like 18 kilometers up to 30 kilometers for the 155?
Yeah, something like that. And the 8-inch went from maybe 14 kilometers up to 30 kilometers too. Big jump.
That reflects the arms race, right?
Yeah.
Even at the tactical level, always pushing for more range, more accuracy, hit targets deeper.
And the shells themselves got way more complex and expensive, I bet.
Oh, for sure. The source lists things like timing assemblies, memory, fancy fuses, power supplies, electronics, sensors, even little rocket motors in some.
Wow. Tiny computers almost inside an artillery shell.
Basically, a long way from just a simple cannonball.
But that complexity also means more things can go wrong, doesn't it? Especially under battlefield conditions.
Good point. Maintenance must have been a challenge. Now, there's a table in the source, table 9.1. It lists some specific guns, like the M109, 155 millimeters, super common. U.S. Army, Marines, tons of NATO allies used it. Italy, Turkey, West Germany.
Right. That standardization was key for NATO. Interoperability, they call it.
Makes logistics and training easier if everyone's using similar kit.
Totally.
Then there's the M198 towed 155 millimeter for the light units, and the M110 8-inch, another big one used by many of the same countries.
So a pretty standardized nuclear artillery force across the alliance.
Looks like it. And looking ahead, well, ahead from the early 80s.
Yeah.
The document mentions the W48, another 155 millimeter nuclear shell planned for deployment around late 86.
And let me guess, enhanced radiation.
Bingo. That capability again. It was apparently going to be the third neutron weapon in the stockpile after the W73 and that W179 we mentioned.
So they were really leaning into that specific type of weapon for tactical use in Europe. Shows continued investment.
Definitely seems that way. Okay, so shifting gears a bit from artillery.
Right.
The document also talks about the Honest John missile.
Ah, yeah. The MGR-1B.
That's the one. Not small thing. Could hit Mach 1.5 apparently.
Pretty fast for back then.
And its range, the B version, was up to about 38 kilometers. And key point, it was dual capable.
Meaning conventional or nuclear warheads.
Exactly. Flexibility for the commanders.
But also potential for confusion, maybe, making sure the right warhead is loaded in a crisis.
Good point. The nuclear version used the W31 warhead, and the yield there was 1 to 20 kilotons.
20 kilotons. That's Nagasaki level.
Yeah. So calling it tactical feels a bit understated, maybe.
Understated, yeah. That's a city-leveling yield, potentially, launched from a battlefield system. Sobering.
The estimate in 83 was maybe 200 nuclear Honest Johns still around.
Okay.
Launched from trucks, basically.
Right.
Self-propelled launchers or towed ones.
Yeah.
And they could carry reloads, maybe up to 6 per launcher.
So quite a bit of mobile nuclear firepower.
And again, Greece and Turkey listed as users. Plus possible storage in the U.S. and maybe warheads kept under U.S. control in South Korea.
That global footprint again. Greece and Turkey right on the edge of the Soviet sphere.
Strategic locations.
Definitely. And South Korea, another major flashpoint. Shows how widespread this stuff was.
Targeting-wise, Honest John was aimed at, enemy headquarters, command posts, big groups of tanks, even their nuclear launchers.
Counterforce targets.
Yeah, and you could choose the burst type, impact on the ground, low air burst, or high air burst, up to 2,000 meters.
That height of burst selection is crucial. Different effects for different targets, air bursts for troops, impact for bunkers, that kind of thing.
Adds tactical flexibility. This missile actually goes way back. Tests started in 51.
Wow, early days of the Cold War.
Yeah. The MGR-1B came into service soon after. Interestingly, the last U.S. unit using it in Korea retired it in 79.
Okay.
They handed the launchers and stuff over to the South Korean forces.
But not the nukes.
Exactly. The document presumes the warheads stayed under U.S. control. That seems to be the pattern.
Alliance cooperation, but ultimate U.S. control over the nuclear component. A delicate balance.
Beyond Honest John, there were other missiles too. The source briefly mentions the Lance missile.
MGM-52C, yeah.
Doesn't go to huge detail, but it was another tactical nuclear system.
And the Lance was quite a bit more modern than Honest John, wasn't it? More mobile, better range, more accurate.
Represents that evolution in missile tech.
Yeah, part of the ongoing modernization push.
Then we get to the Pershing missiles.
Ah, no, these were significant.
The document mentions Pershing 1A as already existing, but the focus is on the Pershing 2, described as a big step up. 2-stage, solid fuel, medium range.
Ballistic missile. Yeah.
Highly accurate, low yield.
Yeah.
Designed specifically for Europe.
And that accuracy was the key thing. It used that radar guidance system, right?
Radar area correlator, yeah.
Yeah.
Sounds like it compared radar scans to an internal map.
Basically letting it find its target with incredible precision deep inside enemy territory.
Game changer, potentially.
Oh, definitely. And hugely controversial. The deployment of Pershing Nucis was a massive political issue in Europe.
I bet. Seen as a direct threat to Soviet command centers and stuff.
Exactly.
Yeah.
Escalatory in their view.
The source even lists the planned bases in West Germany. Neu-Ulm, Neckarsulm, Schwäbisch Gmünd.
Wow, it's specific.
And a training base back in the U.S. at Fort Sill, Oklahoma. Makes it feel very real, doesn't it?
Absolutely. These weren't just plans. They were putting missiles on the ground.
Okay, now for something completely different, but still nuclear.
Uh-oh.
Atomic demolition munitions, ADMs, basically nuclear landmines.
Right. Sounds like something out of science fiction almost.
It kind of does. 2 types listed. The medium ADM, or MADM,
Okay.
yield of 1 to 15 kilotons, weight about 400 pounds, deployed starting in 65. Engineers would place them using jeeps or helicopters.
15 kilotons. That's Hiroshima level as a landmine. Imagine using that to block an advance. Creates a massive radioactive zone.
Shelling. And then there was the special ADM, or SADM.
Special.
Yeah, much smaller, sub-kiloton yield, weighed maybe 150 pounds, deployed from 64.
Okay, so smaller bang.
But this one was man-portable, designed for special forces, commandos, to carry behind enemy lines and plant.
Whoa! So covert nuclear sabotage, that's a whole different level of tactical nuke. Very destabilized.
Totally. The estimate was around 600 ADMs deployed in total.
Where?
Mostly Europe, South Korea, Guam, even some in the U.S. itself.
Guam, interesting.
Yeah, and ADM teams were apparently earmarked for Allied sectors in Central Europe and Italy.
So integrated into NATO defense plans?
And get this, some NATO engineers, British, Dutch, West German units, were also trained to emplace these things.
Wow. So Allied troops trained to handle and deploy U.S. nuclear mines on European soil. The implications.
Yeah. If things went bad, using these to create barriers, destroy bridges, tunnels, the impact on civilians nearby.
Doesn't we're thinking about really.
Now, all these terms can get confusing. The source has a glossary, which is helpful. A few key ones we've touched on. Dual capable reminds us again, many systems could fire conventional or nuclear rounds.
Flexibility and complexity again.
Enhanced radiation, or ER, that's the neutron bomb concept for the W49 and W82. Maximize radiation, minimize blast.
The specialized killing mechanism.
Kiloton weapon, that unit of explosive power, 1,000 tons of TNT, helps put the yields like the W31, up to 20 KT, or the MADM, up to 15 KT, in perspective.
Still huge amounts of energy.
Ballistic missile describes how things like Honest John and Pershing fly, basically coasting after the initial rocket burn.
Unguided for much of the flight, except for advanced systems like Pershing II's terminal guidance.
And height of burst, or HOB, that option on the Honest John, showing they thought about how to detonate for best effect.
Tactical considerations down to the detonation physics, all part of the doctrine.
So, wrapping up this part of the dive into the Army's tactical nukes in the early 80s, what stands out?
Well, first, just the sheer number of them in Europe. Thousands. It really hammers home the reality of the Cold War standoff.
Yeah, not abstract at all. Second, the variety. It wasn't just one thing. Artillery, missiles, even those ADMs. A whole spectrum.
Right. Different tools for different horrible jobs, basically.
And third, the constant development. They weren't standing still. New warheads, like the enhanced radiation ones, show they were refining these weapons, pushing the tech.
A continuous evolution in tactical nuclear thinking.
So hopefully that gives everyone a clearer picture of this pretty unsettling piece of military history.
And it's fascinating, or maybe disturbing, how it connects to today. The specific weapons change, but the strategic dilemmas, the risks, they're still with us.
Absolutely. Which leads to maybe a final thought for this section.
Okay.
Thinking about all those weapons, the numbers, the types, deployed right there. What does that tell us about the risk of escalation back then? How easy would it have been for things to spiral out of control?
That's the million-dollar question, isn't it? The escalation ladder. How do you use a tactical nuke without it leading to all-out strategic exchange?
And how does knowing this history shape how we look at nuclear risks today? Something to chew on.
Definitely food for thought. It wasn't just abstract strategy. It was real hardware, real plans with potentially world-ending consequences.
Speaking of the hardware, that W48 artillery warhead we mentioned earlier,
The 155 millimeter one, yeah. Low yield.
that's the one. There's actually a related story in another document we looked at about what happens after these things are retired.
Oh, like taking them apart.
Exactly. It involves the Pantex plant in Texas, where they disassemble nuclear weapons.
Right, Pantex. That's the main place.
And Lawrence Livermore National Lab, LLNL, they oversee the ones they designed, like the W48.
Okay, so what happened?
Well, back in November 1992, they were dismantling a W48. Part of the process involves removing the high explosive, the conventional stuff packed around the nuclear core, the pit.
Right, got to get the HE off safely.
They use this thermal shock process, dip it in liquid nitrogen, then dunk it in hot water. The expansion contraction is supposed to help separate the parts.
Sounds aggressive for a nuclear weapon component.
Apparently.
Yeah.
Because during this process, with one particular W48 pit, the workers heard a loud snapping sound.
Uh-oh. That doesn't sound good.
Not at all. They pulled it out, inspected it, and found a crack. A crack in the nuclear pit itself.
Whoa. Okay, that's serious. What did they do?
Immediate safety protocols. Evacuated the area, bagged the cracked pit, the whole 9 yards. Major safety concern.
I bet. A cracked pit. You worry about instability, reactions, maybe contamination.
Exactly. They were concerned about potential temperature increases inside the crack and the risk of pyrophoric reactions, materials spontaneously igniting in air. Plutonium can do that.
Right. So a major investigation, I assume.
Oh, yeah. LLNL experts did a huge analysis to figure out why it cracked. Material failure analysis.
What did they find?
They traced it back to a pre-existing flaw, a significant defect in a weld on the outer shell of the pit from when it was originally manufactured.
A manufacturing defect hidden all those years?
Apparently. It was a specific type called a weld lap, basically an overlap that didn't fuse properly. Standard X-rays couldn't detect it.
Wow. So a hidden weakness.
Yeah. It reduced the structural integrity. It was okay just sitting there.
But the thermal shock process.
Exactly. The stress from the hot water dunk interacting with the shell exceeded what the weakened weld could handle. And snap.
So the process itself triggered the failure of a pre-existing flaw.
That was the conclusion. Not just the hot water, but the flawed weld made it vulnerable.
So what was the recommendation? Stop dunking them in hot water?
Basically, yeah. They recommended limiting the temperature the W48 pits were exposed to during handling, keeping it below 65.5 degrees Celsius to avoid similar stresses.
A cautionary tale, then. Shows the complexities and potential dangers even in dismantling these things long after they're retired from service.
Definitely puts a real-world edge on all this talk of hardware. It's not just abstract diagrams.
Not at all. Real materials, real risks. And that actually leads to another point from that same source material.
Yeah.
What do you do with all the other stuff from dismantled weapons, specifically the high explosives?
Ah, right. There must be tons of it. Literally.
Huge quantities, and you can't just burn it anymore. Open burning releases toxic gases. Environmental regulations are much tighter now.
So disposal is a challenge.
Big challenge. Incineration is one option, but there's growing interest in treating these surplus explosives as potential assets.
Assets, like reuse them.
Exactly. Driven by environmental concerns and directives from the Department of Energy, LLNL, again, was looking into ways to reuse this stuff commercially.
Reusing explosives from nuclear weapons. How?
Several ways. Reformulating them into new commercial explosives, recovering explosive powders, or even chemically converting them into totally different, higher value products.
Chemically converting explosives, like what?
Well, one example they gave was converting TNT, common in these old weapons, into something called nitrotoluene diisocyanate, or NTDI.
NTDI. Never heard of it.
Me neither, but apparently it's useful in making plastics, specifically polyurethanes. It could even potentially replace catalysts used in that process.
Huh. Turning bombs into plastic precursors. That's unexpected.
Right. Talk about swords into plowshares, almost.
Almost.
And for explosives that can't be reused, they were exploring other destruction methods besides burning.
Like?
Things like molten salt destruction or even biodegradation using microbes to break the explosives down. The focus is on environmentally friendly methods.
That's encouraging, at least. Finding ways to clean up the legacy.
Yeah, it shows how scientific innovation is needed not just to build these things, but also to deal with them safely and responsibly afterwards, turning a waste problem into maybe a resource.
So from battlefield deployment in the 80s to complex dismantlement in the 90s and trying to recycle the components, it's quite a life cycle.
It really is a long and complicated shadow these weapons cast.
Well, this has been a pretty intense deep dive. We covered a lot of ground.
We certainly did. From thousands of tactical nukes in Europe to the challenges of taking just one apart safely.
Key takeaways again. The sheer scale of U.S. Army tactical nuclear deployment in the 80s, the incredible variety of weapons, the constant push for new tech like enhanced radiation.
And the very real complexities and dangers involved, both in their potential use and their eventual dismantlement.
Hopefully everyone listening feels a bit more informed about this critical, if unnerving, chapter of Cold War history.
And maybe thinking about how that history still shapes our world.
Absolutely. That lingering question remains. How do they manage that risk? And how do we manage nuclear risks today, knowing what we know now?
Lots to ponder. And if you want to explore more, there's always more to learn.
Indeed. Keep asking questions, keep exploring. Thanks for joining us on this deep dive.
Yeah, thanks for listening.